Hello, everyone. My name is Tom Larrow. I'm a DevOps engineer at KeyBank. Again, a little bit about KeyBank. We are a regional bank, top 15 in the country, Fortune 500 company. We got regional offices. We're headquartered in Cleveland. Have other kind of big offices in Albany, Buffalo, and Pittsburgh. Don't have any branches here in Boston, but we do have some in the western part of the state. And I guess you could say our DevOps journey began by incident. We had a major outage that took our online banking system down for almost an entire day. And when you're a bank, that is a major reputational risk. It was in all of the newspapers and all of that. It was a big deal. And so that spawned a lot of kind of self-reflection and investigation into our own system. We're a bank that has grown through acquisition, and when you acquire companies and you plug their systems into yours, you increase complexity exponentially. Through our course of discovery, we realized that one login to our online banking system took over 190 network hops. And a minimum of 6 seconds for somebody to get into our online banking system. And often that was hopping back and forth between our different data centers, between Cleveland and Albany. So we knew we needed to do something to simplify this system. Because the system was so complex, our deployments were 4 times a year, if that, because it was such a big ordeal to do. It was an all hands on deck, 2 o'clock on a Sunday morning, 60 people on a call. It sounded like mission control with everybody giving a no-go for changes. It really was a big deal. So things got rushed to try to make it there because they knew if they didn't make it this release, it was going to be another 4 months before we did another release. Or things would get scrapped at the last second and all those changes would roll another quarter year. So it really was a big problem. So we started to move along, and we were going to do a digital transformation. We were going to design and build a new online banking platform for our customers. The project's name was Digital 17. It was a digital transformation that was supposed to be released in the summer of 2017, right about now. And then our CEO announced that we were acquiring First Niagara Bank. And we were a bank of roughly 2 million customers. First Niagara was a bank of a little over 1 million customers. So it was a major acquisition that was set to close October of last year. And we didn't want the First Niagara customers to come over, be converted to our old system, and then turn right around a few months later and upgrade them to our new system. We had to accelerate our process. We had to go fast. So from a platform perspective, that meant changing how we did business. No longer could we do a request for a VM server and have it sit in somebody's queue for 4 weeks, and then someone else's queue for another 2 weeks while they added the software and patched and so on. We knew we had to modernize the process, and for that we turned to Docker. So we started building all of our online banking components inside Docker containers to move forward and to run eventually into production. But Docker containers themselves, while they're great for having something there that you can test and move forward up through all of your environments, they don't have you need an orchestration layer, and that's where Kubernetes comes in. Kubernetes is Google's kind of their continuation of their Borg project, which orchestrates everything at Google. It allows you to say, hey, I need 4 copies of this running, and it will make sure if one of them dies, it'll spin another one back up. It allows you to also set things to scale based on demand. So if you're under heavy load, it'll automatically spin up and scale new pods. And finally, we turned to Red Hat for service and support. That meant their OpenShift product, which is, again, it's Kubernetes with a little bit of Red Hat frosting on the top. They made some things a little bit nicer. One of the big things is rolling image triggers, which I'll get to in a little bit. But it provides a Docker registry and just kind of some other components around that really makes it go a little bit easier. So in addition to our platform, we had to update our processes. These illustrations are from one of our tech leads, who's a part-time illustrator for highlights for children. It was a big process to go from our quarter releases to small individual commits, to really kind of break it down. And then the one on the far side, we had quite a few debates with our development team. They wanted separate feature branches. They wanted to only integrate right before release. They wanted to kind of continue a lot of the practices that they had been going. And we stepped in and said, no, in order to reach this velocity, in order to go fast, we have to build a process that is continuous so that when you commit, we have automated tests and we can go forward with that. So there was some fairly healthy debate, and they like to remind us of that. So in order to get us going and off the ground running, we initially turned to Jenkins. This was our CI process for our online banking platform. And we really went from doing one deployment to our lower environment every couple weeks, because that's how long it took the QA teams to do their testing in it. And once they cleared it, they would present a big long list of defects they found, and another deployment would come in, and that's how it went. We did that we're doing 20 plus deployments a day to our lowest environment. And that is building the Docker container, spinning it up in our lowest environment. And then you see down there Selenium test as one of our stages. We built a Selenium grid inside of our OpenShift cluster, and that allowed us to throw 20, 30 nodes at the application so that we could test it right away and get immediate feedback to the developer as to whether or not what they changed fixed the problem or made it worse. So once we made it into our dev environment, we had another series of Jenkins jobs that would move it up through each environment. So you would have, once you got it to dev, you would have another job which would move all of the different components up to IT, and then to our QV environment, and then our preview environment, and then finally you had the final job that pushed it to production. So what really made this work was the rolling deployments feature in OpenShift, and this is where these image triggers comes from. This is one of the nice features that OpenShift has over Kubernetes, in that it has the ability to watch a Docker registry for the images. And if that image change, it will automatically trigger a deployment on it. So our CI process was as simple as build the Docker image and push it into the registry and let OpenShift handle the rest. So this is the existing pod that's running. Here I just had one. A new image comes in. It spins the image up, and then it uses what is known as a readiness probe to determine when that is fully up and ready to serve traffic. So your readiness probe is something that you can either just return something that your application is okay. We have in some of our Java web applications some readiness probes that trigger your JDBC connections to make sure the database is there, that it's already there to handle the traffic. Once that second pod is ready, it spins down the other one, and now you're serving this. It works the same way, whether you've got one pod or 10 pods that are deploying. It'll spin them up gradually and spin the other ones down gradually, always making sure that they have the same amount actively serving at a time. So this really was what enabled us to meet those tight deadlines. So we went from doing just a few manual tests in our QV environment to thousands of tests on every build. It was kind of interesting because we were trying to get some metrics on why we were seeing so few defects. And what we were discovering was developers were getting the feedback so quickly that they committed a code, or they committed a code change, everything's still fresh in their mind. They get a report back that, hey, there's 2 new Selenium tests that are failing. They know what they just did because they just did it a few minutes ago. They go in and fix it, and the next build kicks off, builds a new image, deploys a new image, runs the test. Suddenly those issues are fixed. Nobody ever logged the defect. Suddenly, we were struggling to get some metrics on, are we fixing defects or not? Because it was all just happening automatically. So for our big customer day, we actually rolled this out to our existing customers in July of last year. So we really cut a year out of our development plan through acceleration of being able to code faster, being able to deploy faster, being able to find issues quicker. And when we came to October and our time for our first Niagara integration, we had our busiest day ever. We had our 2 million customers, and we had the million customers from First Niagara all wanting to log in to make sure that their money was still in their bank account. They were all hitting it at the same time. And what we discovered was we had a few UI defects. We had some things that were confusing people, and they were locking their account. So we're sitting in the call center, has a 3-hour wait time to reach somebody because everybody's locking out their account. We were able to identify the problem, code the solution, put it through all of our tests, push it up through all of our environments in under 40 minutes. And our call time went from 3 hours to under 45 minutes. So throughout those first 4 days, we did 10 deployments during the day, during our busiest time ever. And we didn't, when those deployments were happening, we didn't take the existing customers out. It just rolled. And a lot of that is due to the nature of OpenShift. So once we got to this point, though, we realized that we had to keep improving. I mean, that's the whole point of DevOps, is to keep improving. We had a huge success and a big win with our online banking that we wanted to spread to a lot of the other applications that we have at the bank. The things we were realizing is that we could not have gotten as far as we did without Jenkins, but we also realized we were kind of at a limit with it. We were missing certain controls. Since we were just taking what was in a certain environment and moving it forward, we had a few incidences where somebody created an extra job to do some other testing, put some code in QV, and then when our job came along to move QV up to production, that went to production. So we didn't have the full controls over that. We also had some audit issues with it. I mean, Jenkins, everything is in a pipeline now, is in code. And to our auditors' dismay, including the list of who can approve or disprove, that's right there in the code. And the auditor said, you mean a developer can decide who can approve their changes? That's not going to fly. So we knew we needed to have something a little bit more robust. And finally, we needed a full enterprise tool. We had an additional deployment tool from one of the large companies that was kind of end of life. And so we had a lot of deployment processes. We had a lot of rigor around this deployment process in this old tool. And what it kind of did was, when we set up our stuff with Jenkins, we had very little. We realized that we needed to find someplace in the middle. We needed something that would provide us the agility and speed that we saw with Jenkins, but still have the controls necessary to move forward. And that's where we did a number of POCs, and we ended up with XebiaLabs. So today, our Jenkins pipeline looks a little bit more like this. We've added a few more tests, code linting, all that kind of stuff in our lower environments. But now when we build a Docker image, and we push it into our registry, and we use XL Deploy to deploy to our lowest environment. And instead, where we were always doing a Docker build, or we were pushing a Docker image that was tagged dev. Now every time we're pushing one that is tagged with a build number. And so we can then we can say, pull that build number and push it, rename it to dev and push that one. So we can control exactly which version is in any environment at any one time. Yeah.
Are you using Jenkins to orchestrate testing as well as code, or are you still Jenkins?
Yes, yeah, we're still using Jenkins to do all of the CI work. And what that does then is that gives us something that we can build a release from. So 20 times a day, we're building and we're deploying to our dev environment. That is creating one of these artifacts that are now available in XL Release to select to create a release. So whereas before we were just taking what happened to be in dev and moving it forward, we can now select exactly which one we want to go. We can say, you know what, the latest one, sure, it passed all of its tests, but we don't necessarily want that one. We can go back to a previous one. So this allows us to have the kind of fine-grained control over exactly what is going through production. So then again, we do have our XL release pipeline, which this is just a small portion of it. We tried not to copy all of the rigor that was in our old system, but we're still figuring out what we need to pare down and pare out of this. But this is all built dynamically. We built a plugin for XL Deploy. So when you go to a specific application, it knows what environments you're deploying to. It knows whether or not a code review is required. All of that is kind of configured, and so it'll build out the steps as needed for that specific application. So in order to do the deployments with XL Deploy, we turned initially to the XL deployment plugin that was in the community on GitHub for XL Deploy. Unfortunately, that kind of the logic that it used was OC new app and OC delete, which deletes the application that's there and creates a new one with the exact same thing. That doesn't give the zero downtime deployments that we had been kind of enjoying and using for so long. But since that process was so simple, I mean, when we POC'd XebiaLabs, the engineer came in and we built a plugin from scratch that just did the Docker pull, the Docker tag, the Docker push. We were up and running in 45 minutes with writing a plugin from scratch. That showed us the value of how quickly we could do that. And we thought to use that a little bit, but this is it was an open source plugin. We knew we could contribute. We knew others might want this same functionality, the ability to use OpenShift's native rolling deployments so that they could do zero downtime. So I coded up the new object type, committed it, and that was accepted, and it's in version 7.1.0 of the plugin. So, and again, using the plugin, Jenkins builds the Docker image and pushes it in. Currently, we're doing it with a Jenkins build number. So, as you see each version there, 1.0.2 114. That was Jenkins build to 114. We're actually kind of in the process of switching this over so that it's more of like the Git hash, so that it's even more related directly to the code, so that the developers can say, okay, this hash committed, went with this code change, built this Docker image that's now in our QV environment. And so, as I showed, it selects the version number, and then you can go from there. And this allows us to, again, we have several different applications that make up our online banking system. It's not truly microservices, but there are several components. And this allows us to kind of select the version of each one that we need. So again, how this Docker push app type works, it issues the Docker pull command to pull the tagged image from the registry. So it's going to pull down one that was tagged version 102.111, and then it retags the image. So it changes the name of the image to whatever you're deploying it to. So if we're deploying to our IT environment, it'll change it to IT. If you're deploying to prod, it'll change it to prod. And then that pushes it right back into the OpenShift registry, which triggers the OpenShift deployment. And then we use the OpenShift APIs to kind of monitor the deployment, make sure everything went okay, that it didn't time out, that that it is fully complete and a good deployment. So the next steps, the things we want to add to the plugin, so is to allow the deployment of updating configurations. So because everything in OpenShift can be code, it's all YAML. You can change how many pods are being deployed. You can change different configurations, all that just by updating the configuration. We want to get that into the plugin so that we can deploy those changes just as we deploy code. The same with configuration maps, which those store like environmental specific information. So if you have different JDBC connections, between your dev environment and your prod environment, this allows you to put the same image all the way through those environments, and then it picks up that configuration.
Is that a feature of OpenShift or XebiaLabs?
It's really that's in Kubernetes. These are all kind of Kubernetes constructs here that I'd like to kind of wrap around and put into the configuration. And finally, secrets are it's configuration maps, but it's all encrypted so that you can do things like passwords for your databases and so on. So this would allow us to update those as a deployment.
Have you looked at using XL Deploy's dictionaries for that?
Yeah, we have, but we want them to kind of live with the source code so that the developers. Yeah, so that developers can change some of those configurations themselves. We're going to maintain some limits in our OpenShift environment, but if the developer knows that having 4 pods of their application versus only 3 will improve performance, we want to be able to let them make that change.
So we have an implementation where we're using the dictionaries, but we actually are using GitHub and Git. We have some code that Jenkins runs, an API script of XL Deploy that updates the dictionaries in XL Deploy.
Oh, yeah, I definitely want to see that. So finally, just some general do's and don'ts. Do question why each step of your process exists. Again, for us, it was kind of a good because we had this existing big process. It did work. But then we also showed that we could get away with doing only 10% of that process. The auditors weren't totally happy with all of that, so we need to find out where the happy middle is. but it has forced the conversation on a lot of things. We had a code review step that we did a quick audit of, and over the past 4 years, or it was a database review of database scripts. Over the past 4 years, it only had been rejected once. So it's always just being rubber stamped, and sometimes it waited all week for a DBA to apply as rubber stamp. Also, do and fail. I mean, that's how you learn. You got to try something, you got to build something, and see what works and what doesn't. I mean, for us, that was, we could not have gotten where we did without Jenkins, but without using it, we also wouldn't have seen where kind of some of the limitations were. And also get the feedback to the developers as soon as possible. I mean, the faster they can get the results of their test run, the faster they can fix it while it's still fresh in their mind. If you're getting their test results, the next day or 2 weeks from now, they forgot what they were working on. They've gone home, they've had a beer. It's not still they've got to re-engage where they were and what they were doing. If you can get it immediately back to them, they can fix it. If you don't spend too much time planning the perfect system. It's going to change, and it really is all change. You build something, you do it, you find out what works and what doesn't, and you keep going. Don't ever think you've mastered something. There's always a new and better way to do it, that's for sure. And don't forget to have fun. I mean, this is cool stuff we get to play with. It is cool to be a part of we have a little dojo at KeyBank, and people are always popping their heads in. It sounds like you guys are having so much fun. Yeah, but we're creating a lot in that. So keep it lighthearted and just keep going. Any other questions? Yeah.
Do you keep your build artifacts in a binary repository, or do they go directly into the Docker container?
So we have, for Docker images, we are currently, it's kind of a combination of both. When we build a Docker image, that goes checked into our Docker registry. But for a lot of the Java web apps that we're building, the output is a Docker image, but part of that Maven process was building the WAR file, which also gets pushed into Nexus. So we're not like pulling straight from Nexus and building our Docker image. It's kind of a, our Maven job actually fully builds the Docker image, but we do then kind of offload that image into Nexus.